All right, let's go over the first question, and the question is, rewrite the expression with a positive rational exponent. Positive rational exponent. This is a rational exponent because it's a fraction, but it's negative, and we got to change it to positive. Let's go over some of the rules. So if you have an x to a negative exponent, you can make it positive by moving it to the denominator. Okay? Becomes positive. So make sure it's the negative exponent that will change to a positive exponent. It's not something like this. This does not equal to 1 over xa, right? Please make sure you understand the difference. This is a negative number. You cannot change it to positive by moving it to the denominator. But this is a negative exponent, can be changed to a positive exponent by moving it to the denominator. Okay? And a simple proof would be the following. If you multiply up and down by x to the power a, any fraction with the same numerator denominator is equal to 1. Multiplying 1 by any number will not change that number, right? Now, according to the rules of exponents, when we multiply, we first of all multiply straight across. We add the exponents. So when you multiply exponent notation, you add the exponents. And this is 1 times any number is the number itself. Now what happens to the numerator? X to the power 0. But we know x to the power 0 is 1. Therefore, that's how we got the negative exponent changed to a positive exponent. So let's go back here. So we have a negative 16 to the power negative 3/2. So that negative sign, I want you to let it outside because the negative 3.5 only covers the 16. If there were a parentheses, then it would be covering both of them. Because there is no parentheses, that negative 3/2 will only cover 16. It does not cover the minus sign, which is here. All right, so all we have to do now, go 1 over that 16 to the minus 3/2 becomes what? 16 to the power plus 3/2. So now we have a positive exponent. All right, let's leave the minus sign outside and let's see what we can do about this. So now we can split this exponent into 16 to the power 1/2, all of it to the power 3. The reason I can do that because look at the rule here. Power to power we multiply, right? If you have an exponent notation raised to another exponent, to simplify the parentheses, you gotta multiply the exponents. And notice here, if you multiply 1/2 times 3 over 1, you would end up with 3/2. So I haven't changed anything by going from here to here. But look what happens next. We know that 16 to the power 1/2 is the same as square root of 16 because this is 1, this is 2. When we change a radical to a rational exponent, we go to the power 1 over 2. But this is equal to 4 because the 4 times 4 is 16. So look what happens now. We have 4 instead of all this parentheses to the power 3. Now we know that 4 times 4 times 4 is 64, right? So that's going to be final answer. Negative 1 over 64 because 4 times 4 is 16 and 16 times 4 is 64. So instead of all this complicated rational expression or exponent, we change it to a negative 1 over 64 as our final answer. So one more we can do is the negative sign is not part of the exponent. That's why I left it outside. That negative exponent, according to this rule, you can move it to the denominator, make the exponent positive. That's what I did here. But 3/2 is nothing but 3 times 1/2, because if you multiply 3 times 1/2, you get 3/2. So using the power to power rule, I split that AB, I put the A inside, B outside, and because A times B is AB, 3 times 1/2 is 3/2. But what is 16 to the power 1/2? 16 to the power 1/2 is nothing but square root of 16, which is 4. So I end up with 4 to the power 3, and that means 4 times 4 times 4, and that's the final answer. Let's go to the next question. Simplify if possible. If you have a cube root that covers the numerator and the denominator, this can be split into two radicals, one for the numerator and one for the denominator. What's the number you multiply by itself 3 times to give you 27? It's just 3. What's the number you multiply by itself 3 times to give you 8? 2. 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. That's the final answer. Use properties of rational exponent to simplify the expression. Write with positive exponent. So when you have the same base and you are multiplying, like in this case, if there is no operation here, then that must be multiplication. We use that rule. X to the power a with the same base, x to the power b, we add the exponents. So because we have the same base, we add the exponents. So that's going to be equal to 3 plus 5, 8 over 8. And what is 8 over 8? Is 1, which is x. We don't have to write x to the power 1 because we all know if there is no exponent, it is 1. Use the radical notation to rewrite the expression. Simplify if possible. So again, we have 121 to the power 1/2. Remember, we can put this inside the radical. The 121 sits here. This is the exponent. This is the index. So 121 to the power 1 over 2. What is the square root? What is the number you multiply by itself to give you 121? That's 11. 11 times 11, 121. Use the radical notation to rewrite the expression. Simplify if possible. So 64 to the power 2/3 is equal to, we put a radical, that is the 64 squared, and the index is 3. See, so this is how we change a radical notation to a rational exponent. We go 64 to the power 2 over 3, and that's how we got here. Now let's try to simplify. Notice that 64 is nothing but 8 times 8, and 8 is nothing but 2 cubed. So this is what we have here. 2 cubed times 2 cubed, all of it to the power 2, because what is 8 times 8? 2 cubed is 8, 2 cubed is 8, 8 times 8 is 64. So I haven't changed anything, but this is what I can do here now. 2 cubed times 2 cubed, they have the same base. I can add the exponent. So this is 2 to the power 6, all of it squared. Now I apply the power to power. I multiply. So now I have 2 to the power 12. And finally, I'm going to change this radical to rational exponent by applying the rule 2 to the power 12 over 3. Now what is 12 over 3? That's 2 to the power 4. 2 multiplied by itself 4 times. That's 16. So remember, 2 times 2 times 2 times 2. 4. 4 times 2, 8. 8 times 2, 16. So 16 is the final answer. So 64 to the power 2/3 is equal to 16. Again, we started by changing the rational exponent notation to a radical notation. 64 to the power 2 over 3. We go back here. But 64 is 8 times 8. 8 is 2 to the power 3 times 2 to the power 3. 8 times 8, 64. Haven't changed anything. Multiplying exponent notation, we add the exponent. 3 plus 3 is 6. So 2 to the power 6 now to the power 2. Power to power. Remember the rule, if you have power to a power, you multiply the exponents. So 6 times 2 is 12. Now we're going to go back to rational exponent. 2 to the power 12 over 3. 12 over 3 is 4. 2 times 2 times 2 times 2 is 16. Rewrite the expression with rational exponent. So this is called radical notation. This is 1. If there is no index here, it should be 2. So 7 to the power 1 over 2 would be the rational exponent, right? So 1 over 2, 1 over 2. That's called the rational exponent. This is called the radical notation. Simplify if possible. What's the number you multiply by itself to give you 144? That's going to be 12. But so all this is 12. So we have to save the minus sign. So the answer is negative 12. Remember that 12 times 12 is 144. Right? So now the square root of 144 is 12, but then we have a negative sign, so we got to save the negative sign in the final answer. Find the domain of the function. So the radical, we want to make sure the radicand, this is called the radicand, 70 minus 10x, must be greater than or equal to 0, because the square root of a negative number, square root of negative 5, is going to be a complex number. So it's not real, right? It's an imaginary number. So make sure that the radicand, or the number under the radical, must be greater than or equal to 0. Let's solve. Subtract 70 from both sides. So that's going to be negative 10x greater than or equal to negative 70. Now divide both sides by negative 10. Flip the symbol. So every time you divide or multiply an inequality by a negative number, you must flip the symbol. Divide both sides by negative 10. So the 10s will cancel, the negative will cancel, x is less than or equal. The negative will cancel, 70 over 10 is just 7. Final answer. X is less than or equal to 7 is the domain of the function. So x can be any value. If you want to draw this on the real number line, this is 0, this is 7. So you have a square bracket, and it can have anything less than 7 up to minus infinity, including 7. That's why I have a square bracket. Okay, if you have a less than 7, you would use parentheses. Given the function, find the indicated value, f of negative 2. So by f of negative 2 means I have to replace the x by negative 2. Replace the x by negative 2. So that's going to be square root of negative 2 minus 2 quantity squared. This is equal to negative 2 is negative 4 quantity squared. This is equal to negative 4 times negative 4 is 16, and the square root of 16 is plus 4. So again, all you have to do, replace the x by negative 2, but you don't cancel here. These, they don't cancel. You lost $2, and then you lost $2. You lost $4. When you square it, negative times negative is positive. 4 times 4, 16. The square root of 16 is 4. Divide and simplify if possible. Since these two have the same index 3, I can put them under the same radical. That would be the best way to start this problem. Cube root of 32x10 divided by 4x. Now I can simplify the inside the radical. So let's go back and write cube root. What is 32 divided by 4? 8 times 4, 32. So that would be 8. When you divide, here is the rule for division. X to the power a over x to the power b. Having the same base, I can subtract the numerator minus the denominator. So this is 1. 10 minus 1 is 9. So this is x to the power 9. 10 minus 1. But you know that cube root of 8 is 2. And this one I can change to a rational exponent. So here is what we can do. I can split this into two radicals. Cube root of 8 times cube root of 9. X to the power 9. Now 8 is, what's the number you multiply by itself 3 times to give you 8? 2 times 2 times 2. So that's 2. This one, I can change it to a rational exponent by going x to the power 9 divided by 3. So this is radical notation. and this is rational exponent. It's very important to know how to change from one notation to the other, because what is 9 divided by 3? It's 3. So we're done. This would be the final answer, 2x cubed.